Hello team, today's challenge is ISBN-10 Validator, where we're given something that looks like an ISBN number, and we need to return if it is true or false based on some rules. The first 9 digits, the first 9 characters must be digits. The last one can be a digit or an X, which represents 10. And then here are the actual validation rules. So we need to multiply each digit by essentially its index plus 1 to make it easy. That's what we're going to do today. So this would be index 0. We're going to add 1 to that. So it's going to be 0 times 1, which in this case is always 0. But hopefully that makes sense. And then 2, 3, 4, all the way to 10, just like that. And if it all divides cleanly by 11, right, if there are no remainders when we divide by 11, then it's valid, okay? There is a thing in here that I will talk about in a bit. So something about how I learned about ISBN 10, but it still works. So we're going to do this, then we'll talk about that, and then we will wrap it up, okay? So over here, we have the code. We are going to start by taking our string, okay? Our string currently has dashes. We don't want dashes, okay? We want to get rid of all those because really we just want the digits and the final X, if it is an X, okay? So we are going to replace all. That will be a dash. We'll replace it with nothingness. Brilliant, okay? Small catch here. Something that they don't talk about, and all of their examples have a capital X. Is there any time where we might get a lowercase x, right? Through the process of how it came out of a database or something like that? Can we guarantee that it will ever be an X? I think that's a no, right? And because I think that's a no, I'm going to go right between the string and the replace all, and I'm going to go to uppercase, just like this. That probably could have also gone at the end, but this ensures that we always have a capital X. So we're taking care of that right away. Again, for today's test cases, doesn't matter, but for real stuff, we definitely want to be thinking about will that string always be guaranteed to maintain its shape, right? Maintain that it's always uppercase or lowercase, whatever. If not, we protect ourselves, okay? Down here, we have our conditional, okay? And our conditional is going to be a regular expression, okay? Inside of here, we are going to start and end. So start and end, we'll start with digits. We want 9 of them. So 9 just like this. It's weird that it didn't autocomplete that, but that's okay. So it will have 9 digits, or it will have, not or, and then, so after those 9 digits, it will be either another digit or an X capitalized, right? Because we did the uppercase up here. So we're guaranteed to do that. Now, if that is true, we test against the string. So if that is true, we're going to do something. But what we want here is to test if that is not true. So right at the beginning, we had that exclamation, that bang, right? To say, if this is not true, then go and return false, okay? Just like that. Again, if you didn't have uppercase, you could add in an I in here, right? For case insensitive. But because we've already uppercased it, it should be pretty safe, okay? So again, if it doesn't follow this format where it begins with 9 characters and ends with, begins with 9 digits and ends with either 1 digit or an X, right? Then it's false. We don't need to go any further. We can just kick it out the door. Down here, we want to tally up, okay? We want to get the total of all these numbers multiplied by their index plus 1 in order to get a number that we can divide by 11, okay? So for that, I'm going to take that string. Whoops, I'm going to add a name for my variable and then take that string, which should be an array, right? Because what we're going to do is we are going to reduce, right? So the accumulator, the current, And this time we need the index, right? That's how we know which thing. I also forgot an extra dot. Thank you, Linting, for telling me that. Brilliant. So accumulator, current, and index, okay? Right here, we start off with 0, but inside of here, we are going to do something. The first thing that we need to do is take care of that x, okay? If it's an x, how do we add that, right? We need to make sure that it's a 10. So we're going to take the current, just like we did with string up here, and we're going to set it to current equals capital X, because we uppercased everything. We can do that. If that's true, it's a 10. Otherwise, it's just current, spacing this out, making it right. And then from there, we return, okay? We return the accumulator plus our current times index plus 1, right? And we need index plus 1 to happen first before doing the multiplication, before doing the addition, okay? So this order of operations tells us that this will work. But here we go, okay? With all that said and done, down here, we are pretty much done. We just need to modulo, where is it here? Modulo 11, and make sure that that is equal to 0, okay? At which point it works, which is great. Right, we did the work. We got rid of the dashes. We checked to make sure that it was actually the right format, right? If we hadn't uppercased it, we might have to do 1 or 2 extra regular expressions. But because we uppercased it, we were able to just test against a capital X instead of capital and lowercase, right? Uppercase and lowercase. So a few extra bits here where that uppercase really helped us. And then we checked it, right? We returned true or false based on whether we could divide by 11, right? Now, the way that I learned this, and the thing that I was hinting at the very, very beginning, okay? When I learned this, I learned that the way that they want this to work is you do it in descending order, descending from 10 to 1. So if you look at the math, it's 10 times the first digit, 9 times the second digit, 8 times the third digit, and so on, etc., until you get to that control character where it's just, well, it's 1 times that character, right? And then you mod 11 to get 0, right? So I was always taught that it was descending order, right? But this very much isn't, right? They asked us to do it in ascending order, where we start with the 1, and then the 2, and then the 3. And after taking a look, I found out that yes, it actually works in both ways. So in that strange coincidence, ISBN is very robust, right? You can do this math forward or backwards. It doesn't matter. If I wanted to stay the course and follow the actual spec, I could go back here and just do a reduceRight, and it still works, right? So forward or backward really doesn't matter. I would probably go backward just to stay with the spec, just to make sure that I'm aligning with that. But it doesn't matter, which is fun to know, okay? With all that said and done, this is it for today. Again, not every solution, just hopefully one good solution. Did you find it interesting? Did you like it? Did you hate it? Did you find a different way? Let me know all that stuff in the comments. Otherwise, today this has been ISBN 10 Validator, and I will see you tomorrow.